Hello all you beautiful people, and welcome to another episode of An Ecologist Plays. Today we've got quite a few things to do. We are obviously going to be listening this new radio message we've got here, and then we are going to go out exploring a little bit more in the coral reef area where we are today, or where we are at the moment, and then we're going out into the Kelp Beds to go look at some more things there. And then last time I also did mention a creature that made a big bellowing sound somewhere in the distance, and we are going to go and have a look and see if we can find them. So stay tuned and let's see what we find. Let's start out by listening a bit to this new radio message we've got here and see what new information that gives us.
This is Avery Quinn of Trading Ship Sunbeam. Aurora, do you read? Over. Nothing but vacuum. These Altera ships. They run low on engine grease, send an SOS, you offer help, they don't pick up. Aurora, I'm out on the far side of the system. It's going to take more than a week to reach your position. Do you still need our assistance? Over. I'll try them again tomorrow. Damn charter's gonna have us blowing our credits running errands for Altera. See what the long-range scans pick up in the meantime.
Okay, so the Sunbeam we are going to hopefully encounter if they come to try and rescue us. Let's hope they manage to find us. In the meantime, I'm just going to go out, explore a bit, and see if I find anything interesting. So I'll be back with you as soon as I find something noteworthy.
Emergency. A quantum detonation has occurred in the Aurora's drive core. The reactor will reach a supercritical state in T-minus 10, 9, 8...
So something's happening here, something big. There's a bit of drama at the Aurora, and okay. Right. Debris flying all over the place. And okay, it seems we now have radiation present in some parts of the water. Okay, now I was just minding my own business. I had been looking for some metal throughout the environment. I had just come back to the escape pod to get something to drink and to eat, and then we had that bit of an explosion. So it is now daytime. I'm just going to finish up here, get something more to drink, and then we'll probably go explore a little bit into the grassy biome, the blood grass biome that I'll show you in a moment. So I'll see you then. Okay, so I've just finished up getting all my vital signs ready again. We are going a bit through the kelp bed environment here, and I'll talk about that later in the episode. As you can see, the water here is quite murky, and there's a very, very good reason for that. Let's see, have we scanned this hoverfish? It seems we have. So let's have a look at the hoverfish. The hoverfish is a small fish species that feeds almost exclusively on kelp and soft lichen, and is most abundant therefore in kelp beds, where there is an abundance of food. The features of this species, especially its smooth skin and frog-like face, indicate that there is potentially an amphibian ancestry here. Additionally, the 6 legs have spad-like tips, reminiscent of reed frogs and tree frogs which are found on Earth, especially in Africa. These pads seem to move in an undulating manner, allowing it to hover through the water, hence the name hoverfish, similar to how cuttlefish manages to hover in the water. Okay, fascinating little creature. Which I'm just going to get some more metal now, get some more stuff, and I'll meet you back in the bloodgrass area in a moment. So this is the bloodgrass environment, and it's characterized by this.
Local scans show a nearby cave entrance, depth 90 meters, leading to an unknown environmental biome.
Okay. Before I was so rudely interrupted, the bloodgrass area, or this biome, is characterized by these blood red plants known as blood grass, hence the whole area is called that. Now this is actually quite weird because normally... Okay, so I can only go up to 100 meters before oxygen becomes an issue. Now, normally it wouldn't look this red if you are 88 meters underwater. Oh, there's something big. We're going to go up to him in a moment. Now, the way light works is that as it penetrates water, it actually, less light or less of the spectrum will go through the area or go through the water and actually reach deeper waters. So in shallow waters, like in the coral reef or in the safe shallows, there will be our life pod is, that's generally quite brightly colored. Light will penetrate the water and most of the light will then be reflected off the surfaces and back to our eyes, to what we can see then. Which is why if you go diving in shallow reefs, you've got bright colors. You've got red and blue and purple and green, all kinds of colors that you can perceive. As you go down, so as we go down here, less light is actually penetrates. More of the light spectrum is absorbed. And when I refer to the light spectrum, if you look at a rainbow, for example, that's the white light that comes from the sunlight that's broken up into the different frequencies that we pick up. Red light, green light, and blue light, the three primary colors in terms of light, not to be confused with the three primary colors of paint. But with light, red, green, and blue are the three wavelengths that we mostly talk about. We also have ultraviolet and infrared. Infrared light gets lost within the first few centimeters of the ocean water. As you then go deeper down, at about 30 meters, most red light is actually gone. So up until this point, you would be able to see red. After this, your blood, if you get cut, for example, would not appear red. Generally, that will then appear green. Color that we perceive is simply based off what part of the light spectrum is bounced off an object and is perceived by our eyes. Now this 30 meters here also refers not only to depth but distance as well. So if I were to bob just below the surface here and look at something that's about 40 meters away, it would also not appear red to me, even if it is actually red. Now they've managed to get that quite right here with the green here, with the kelp. Normally, if you go closer, the green things would appear green. Further away, you wouldn't be able to pick up green, as that's one of the things that gets lost. So infrared first, then red light will get lost, then green light, and blue light is the one that penetrates easiest or deepest through water. So generally, as we go deeper down, and this does depend on a variety of things, but generally as we go deeper down, red light or fewer things will appear red, then fewer things will appear green, and then lastly things that we will be able to see would be blue in color. Now it could be that the sun here is brighter and more light actually reaches the surface, or it could be that on this planet water is slightly different compared to our oceans and light then penetrates deeper, so who knows. But overall, normally blood grass like this would not appear red to our eyes, simply because at this point there is no more red of the red part of the spectrum of light that actually penetrates to this point to then be reflected off to our eyes to actually pick it up. Now, while we are here, and we could hear him a moment ago, let's have a look at the giant. So this creature here is our first Leviathan class organism. First of the large creatures that we will encounter in this game. And it is known as a Reefback. So called because on the back of it you will find entire reef systems actually growing, and it supports a whole ecosystem on it. Oh, I just detected radiation there where I was swimming, so I should sort something out before I go further in that direction. Oh. So obviously this plant or this organism here, this Reefback, is based on whales that we've got on Earth, which obviously are also quite large. I've got no problem with swimming this close to something this big in this case, because it is most likely a filter feeder. Based on the sluggish nature of these creatures, most of your filter feeder organisms would be able to, most of these large creatures would be filter feeders. Now, there are, of course, some exceptions. There are some large predators in the oceans, or there used to be as well. Basilosaurus, for example, was a massive whale that was able to get that size based on the presence of lots of prey items back in the day when it survived. We also had, of course, Megalodon, which was a massive shark that survived in our oceans, but they obviously died out a long time ago, despite what some mockumentaries would tell you. And they were able to survive because of the presence of lots of prey, which then enabled them to get to that size and find enough food to survive. On our current day, we don't have enough prey, and we don't have large enough prey for something like a Megalodon to survive. However, filter feeders like our blue whale on Earth and the Reefback on planet 4546b are able to find enough food in order to survive if there is enough phytoplankton or single-celled algae and diatoms and things like that present in the water. Swimming just below the surface of planet 4546b, a giant, the Reefback Leviathan. Despite its massive size, this is a gentle creature and feeds on plankton in the euphotic zone of the ocean, where sunlight and nutrients result in an abundance of phytoplankton. Unlike Earth's whales, which are vertebrates, the Reefback is an invertebrate and covered by a shell made of chitin, and this is a trait that is observed in insects on Earth, and it enables it to, once large enough, be immune to attacks by any carnivorous species still present on the planet. Like the sloth on Earth, this creature's slow movement promotes the growth of organisms on it, but instead of the algae present on sloths, a Reefback is covered by a variety of reef-occurring species. This microcosm attracts a variety of shoaling fish, with the juveniles of many species seeking shelter around this leviathan. Similarly, on Earth, many small fish will hover around large, slow-moving herbivorous fish, such as whale sharks. On the underside of this creature are massive pods containing digestive enzymes, used to digest the phytoplankton externally before it is slurped up by the Reefback. This is similar to octopus feeding, where an octopus that has captured the mussel will extrude its stomach into the mussel's body cavity, digest it externally, and then slurp up the mussel smoothie. The Reefback is usually found in pods of 2 or more individuals, and their mournful bellowing calls echo through the ocean as they keep contact with the rest of the pod. Okay, so we're back in the life pod, and while we are here, I'm just going to listen to this little radio message here. And while we're listening to that, I'm also just going to get the radiation suit ready.
This is Ozzy from the cafeteria. What the hell, guys? They didn't warn us this might happen. Our pod was almost crushed by this Seamoth Bay on the way down. Now we're hanging on the edge of a cave system, and this grim-looking snake thing's trying to eat through the hull. Come get us already.
Signal location uploaded to PDA.
Okay, so Ozzy doesn't sound very happy about the fact that he's had his whole area crushed almost by the Seamoth Bay. So we've got a new location which we are going to be looking at in a bit. It's the LifePod 17 over there. Now I still need some of the creep vine here, which I can cut and hopefully then get the fiber mesh which I need in order to make our radiation suit so that we can go and explore a little bit further afield. Okay, and here we go. Now later on we will be able to get some other suits. We've got a what else have we got? We've got a reinforced swimsuit that will make us, or which will enable us to be more resistant to damage. We've got all kinds of things which we can get. However, for now we need the radiation suit until we find a way to get or to repair the Aurora, the big ship that we crashed in or crashed with. So there it is. Now I'm going to go out while it is nighttime now. I'm going to go explore looking for some more parts for the first submarine, which we'll be able to make, and I will be back with you then in a moment. Now, I thought it is actually quite important for me to, while it is nighttime, also talk about a few things here. First of all, you'll find that many organisms will have their rhythms of activity, periods that they are most active in. A lot of these creatures, like the peepers, the fish, little fish here, the bladderfish, the boomerang fish here, all of them are more diurnal, meaning that they are active during the daylight hours. Some other species will be more active during nighttime. While we are here, let's scan the peeper. And some of them are a little bit more crepuscular, which means that they are active in nighttime and daytime. Now, fish like this one here, the peeper, with a very large eyes, they would be able to see quite well in darker conditions. So during nighttime, whoops, something's not happy with us. Oh, that was a crash fish. Others like this little guy here, the bladderfish, are not very good in terms of being active at night. They are strongly diurnal, and they are not very active at night. The boomerang fish here also, if we were to go and scan him, we also find that they are typical diurnal fish, only really swimming away if we get closer. Now, notice with the boomerang fish here, the ones obviously shaped like boomerangs, they have got two eyes on each side of their head, giving them very good vision on all sides, but also they've got these bright white tips. Again, this is now bioluminescence. If I were to go and pick him up, if I were to hold him in my hand, you can see the white tip on the edge of its fins here. Now, this is where part of its digestive tract, in this case, so part of where the food comes from, or well, passes through. And the white bioluminescence there comes from the coral that they eat. So in terms of their food, they are herbivores feeding on coral and then concentrating some of the bioluminescence in the tips of their tails. Now, this may sound like something quite out of science fiction. However, on Earth there are also quite a few organisms that will take parts of their food and keep that in their bodies. There's a snail known as Glaucus atlanticus, which is a good example of this. It's a nudibranch, meaning basically a sea slug, that feeds on blue bottles and other things with stinging cells. And they then take the stinging cells of the prey items and actually put that in their bodies. And that gives them a form of defense. Now, in the case of the boomerang here, it is quite possible that they use this as a way to keep track of one another, because as you are swimming behind it, you can see the bright bit in front there. So for shoals to probably keep together, so whole groups to stay together and easily track where other members are, because it is a good form of defense, safety in numbers. If you are the only one in an area, it's quite easy for predators to single you out. If you are one of 20 individuals, there's only a 5% chance that you are going to be the one that gets caught. So safety in numbers, a very good strategy, and it's quite possible that the bioluminescence of the boomerang here on the tips help them to keep track of one another and find one another, especially in murkier conditions and at night, when lots of predators are most likely active and the prey, the boomerang here, are not very active. So I'm just going to be making a compass for myself now, which will be very, very useful as we go out exploring a little bit more. We need copper wire and a wiring kit, and this will allow me to also keep track of where we are going and where we have gone, and also then so that I don't get lost and I can actually draw up a rudimentary map, which I find very useful usually. Okay, so we'll now have the compass, which you can see at the top there. You can see as I turn around, it switches around in different directions, which will allow me to then basically have a good idea of where we are and where we are going, and draw up a rudimentary map, because this game does not have a map. There's no way for you to just quickly pop up. Oh, you can. I don't want to do that. There's no way to, within the game itself. You can with mods and stuff like that, you can get maps, but there's no way within the game to actually have a map. You've got to basically memorize where everything is and use things like those markers, the waypoints, the beacons, to keep track of where you have gone and where you still need to go. And we're back in the life pod. I was just out exploring, getting everything ready to make our mobile vehicle base so that we can get ready to make our first little submarine, tiny little one called the Seamoth. And while I was out, there was another message that came through to the radio. So while we listen to that, I'm just going to basically make our little mobile vehicle bay so that we can start getting ready for exploring a little bit more.
Aurora, this is Sunbeam again. We just picked up a massive debris field at your location. I didn't know how many of you... I didn't know. We're now en route to your location. We're gonna bring you home. Sunbeam out. What else can I say? The only time I parked a rig this big on a rock that small was in VR, and I blew it. It's a bad option, all right, but so are all the others.
Okay, so the Sunbeam is hopefully going to come to us to try and rescue us. And in the meantime, we are going to try and rescue ourselves. And the first step to doing that is this, the mobile vehicle bay, which we will now deploy in the water around here somewhere. Let's see, where's a good spot? Here's a good spot. Okay, so let's put that in our hotkeys here. And let's release it. Okay. Now, from here, we should then be able to make our first vehicle, which is the Seamoth. However, I still need to go and find some more fragments. As we look over here in terms of blueprints for the... Where is it now? The Seamoth. There are 3 fragments that I need in order to actually be able to make it. I've only got 1 fragment thus far. Okay, there was a gasopod that just attacked me at the top. Like, why? I'm standing, minding my own business, and it just dropped gas on me. That is not a nice thing to do, Mr. Gasopod. Now, you'll see my health did recover a little bit there as well. That's the whole idea with defensive mechanisms, especially if you're using toxins like the gasopod does. It doesn't want to kill an individual. It just wants to scare the predator off so that the predator knows to avoid it in future. And yeah, that's basically what a lot of prey animals will do. The problem with killing a predator or something that comes too close and wants to attack you and you want to scare it away, if you kill it, it hasn't learned a lesson because you've not just gonna kill it. If, however, you teach it a lesson by poisoning them, making them feel bad, or, well, ill, and not very good, then that way they learn a lesson to avoid organisms that either look a certain way or taste a certain way, and eventually they basically learn their lesson. So lots of toxic creatures aren't out to kill their predator. There are obviously exceptions, things like the crashfish, which we will talk about at some point as well. They're definitely there to go and kill whatever is threatening them. And then on Earth, things like the poison dart frog is also there not to basically teach you a lesson but to kill you outright, because they are so toxic that you basically die when you go and try and eat them. So the gasopod here was just trying to scare me away, I guess. Now I'm just going to pop in here at the life pod 17, where we had Ozzy. He was one of the guys on the ship here, and well, he was, last we heard, he was very unhappy. There is also a Seamoth fragment, so this is what I'm looking for in terms of getting our little submarine up and running. So if I can find another one of these, we should then be able to make our first little submarine. But let's hear what Mr. Ozzy here has to say.
Ozzy's log. It's the day of the crash. I don't know what the heck is happening. I'm scared and I'm not going outside. There are shadows in the water under the hatch, but I can't tell if they're rocks or aliens. And there's weird-looking caves nearby. The Aurora was carrying everything needed to build the phase gate. Mobile vehicle bays, bioreactors, propulsion cannons. It had a cinema. There was a zero-G gym. My cafe. I don't understand how we're here now. I don't know why no one's coming for me.
100 meters. Oxygen efficiency decreased.
So if we have a look down here, we can see the weird caves that are nearby. A little taste of things to come. Now, we do not have the equipment to go down there yet and survive. We are going to have to go beyond 100 meters, which is not possible really for us to stay down there for long periods of time. So we are going to have to first get some more equipment. The first thing to do would be to find the last fragment of the Seamoth and to have a little ship, make a little submarine to go down there. And that's what I'm going to be quickly doing. I can see it over there. I'm going to scan it, and then I'll go home and I'll meet you back ready to make our Seamoth. Okay, so I've gotten everything ready to make our first Seamoth, and we have another message on the radio, so let's play that and listen to it while I go and make our Seamoth, our first little submarine.
This is Officer Keen in Light Pod 19. The captain is gone. I have assumed command. The last thing the captain did was give me coordinates for dry land. We regroup 1.5 kilometers southwest of the crash site. Stay together and good luck. This message will now repeat.
Rendezvous coordinates corrupted. Transmission origin coordinates downloaded. Signal location uploaded to PDA. The Seamoth is a fast, safe mode of transport, but remember that swimming is good for your glutes and endorphin levels.
Okay.
Welcome aboard, Captain.
So this is our first little, submarine. We are later on going to make a massive one, but for now this is what we are going to be using. The Seamoth, which is an amazing, versatile, as it says there, little submarine. And we're going to be mostly swimming around with this. It has a crush depth of 200 meters, so we can go down 200 meters quite safely. We can be destroyed, or the ship can be destroyed by larger things, and if we crash into things like that spadefish there, it can also damage us, so we have to still be relatively careful. I'm just going to wait here or explore a bit and wait for daylight to come around, and when it does, we're just going to talk a little bit more about the kelp beds that we've got over there. Okay, now it is now daytime, so we can see properly again. I just want to talk briefly about the kelp beds that we've got here. Now, kelp are basically algae, large, very, very large algae, and these are the forests of the marine ecosystem. And there are generally good reasons why kelp beds are located where they generally are. Here where I am in South Africa, our kelp beds are very often located along our west coast, where the wind will blow, especially during the summer months, will blow from inland out over to the seaside, and that pushes water ahead, and the water that gets displaced by the wind will then have to be replaced from somewhere, and that water will come from deeper down, and that then circulates water through the area. So as water gets pushed offshore, the water from deeper down will circulate up, and in the process it brings the nutrients down from the deeper water into the shallower environment. Kelp and other algae generally cannot take up nutrients unless it is suspended in the water. As they are algae, they take up the nutrients from the water, not from their root-like rhizoids or their root-like structures which they would have. Those are not for taking up nutrients. Instead, they will take up nutrients from their leaves, their fronds, and their stems. And with the nutrient upwelling, that's what it's called, when nutrients from deeper water gets welled up into the shallower water. As that happens, it's suddenly a very nutrient-rich environment. Perfect for algae like the kelp over here. Now, apart from kelp, you also have phytoplankton, the single-celled algae, which will do very well in this under these conditions, and that often makes the water very murky, gives the water that murky color that we pass through here, not only the nutrients present, but also the algae that's blooming in this environment. And this abundance of nutrients and food or filter or algae will then support all your filter feeders. And here we can see whole shoals of fish moving through the environment here, most likely filtering out the dense groups of algae present in the water here. And then, of course, that will then support lots of predators which will be feeding on the fish, like the hoopfish or the spinefish there, things like the stalkers, which we saw in the previous episode. They will then obviously feed on the herbivores. So you've got a whole food web, a whole forest ecosystem underwater here, basically dependent on nutrients coming up from the deeper water into the shallower water. And you won't have the kelp here growing way down there in the deeper environment because they need sunlight to photosynthesize. If the water is too deep, as I mentioned earlier, less light will actually penetrate the water. So up to a point, there will be enough sunlight to have the little algae, the sporling grow so that they can then grow big enough to actually establish. But if the water is in South Africa more than 30 meters deep, you generally don't have the kelp growing because they can't establish. The little sporelings that establish will not have enough light to photosynthesize and then to actually grow to these heights. They will basically be eaten before they have a chance to really get enough energy to grow to the higher height. It's quite a complex thing that happens, but basically kelp beds here would be found in water that's relatively shallow. If we have a look here, we are currently 60 meters underwater, and that's the basically 70-80 meters here would be the limit for the kelp to actually grow. Here we've got our predator, the Stalker. Hello. We are quite safe from him in our little Seamoth here. He'll probably try to attack us without doing any damage to our Seamoth here. Oh, just grabbed a hoverfish there. Using their very narrow snouts there, as I've mentioned last time, they use that to have very nice effective bite force and catch their prey with those very jagged teeth. And there he is, probably going after another little fish. Not the fastest of creatures, but quite maneuverable with those dorsal spines that I also mentioned last time. Those spines on the back giving them a bit of maneuverability. The strong tail fluke there, very reminiscent of a dolphin, which has very similar tail fluke there, the tip of the tail. And that enables them to get quite a turn of speed, but not fast enough to keep up with us if we are really getting a move on. He's just trying to get enough food to, well, support himself. But that is basically almost where we're going to end today's episode. There is one more thing, and that is next time we are going to go not to the Aurora. We are going to go in
Increased foreign bacterial levels in the water.
Okay.
Performing a self-scan is advised.
We are going to go in that direction, because there's something that tells me that over there where we've got cloudy conditions, there's something that we've got to go and investigate over there. And we're also going to next time then scan ourselves to find out whether anything is wrong, as our PDA just told us that there's a lot of foreign bacteria in the water, which obviously it might be a good idea to check up on that next time. So if you enjoyed our episode today, remember to leave a like below, and if you want, subscribe, and then you'll get a notification when the next video is uploaded. Until next time, stay safe. I'll see you next time.